All right, so we talk quickly. This is a function pointer. You're passing a function to a function. This is done a lot. In fact, this is how inheritance is generally implemented. But what's the idea here? Well, you want to parameterize what action you are taking. A very common tool or technique is that you want to pass a function to the data structure, and you want this function to be called on every single element. Maybe you want to sum them, maybe you want to print them, maybe you want to put them all in a database, whatever. But the idea is we want to just have one function that you can pass the function to, and it'll just execute it all, or execute on each element. Okay. Oh, by the way, side comment, this code is not correct. You will probably get a seg fault from the autograder. Yeah. Hopefully, actually, does anyone know what the issue is?
There is a null check missing.
Yeah, there's one right here. What if I call remove? Oh, well, actually, if I call remove and root is null, there's the null check. So it's there.
But the node arrow left, arrow val, need check if left is. Oh, we already did that.
Yep.
I already saw another one somewhere.
What if we delete the root? Ooh. Because there's no parent. Yeah. Because if we're trying to delete the root and there's no parent, then this whole delete left and right thing doesn't really work because we're assuming we have access to the parent. Y'all got this. Now forget about that for a moment. Back to what we're doing, which is iterating, calling visit on each thing. Okay, great. Well, didn't we already do this somewhat? With traversal post order? There it is. Pre-order right, there we are. Okay. So the idea here is that we are going to go down here and we'll probably have a void visit, and it's passed a pointer to a function that's also passed a value. Ooh, that's a lot of visiting going on. Let's change these numbers. Yeah, that might make a little more sense. Okay. I wonder if I typed that correctly. I did, great. Well, for each of these elements, we want to visit. All right, what do we do?
Do I copy code from something?
You mean Stack Overflow, right?
No, like in this file. It does
There.
How do you do that?
Is why, well, there's lots of ways.
So
take your pick.
Which section do you want to copy?
The iterative contains.
The contains.
The
Well,
iterative. Maybe
remember, we don't want to search. We're not searching for something. We're doing something for each one of them.
I guess the pre-order or post-order or something.
Sure. You said pre-order. Yeah, we'll copy this. Hey, pre-order is recursive, so let's make a separate function for each rec. And then we're going to hey, I went in autopilot. Okay. mean, is that what we want? I doubt it.
Yeah, now we're just gonna make it so instead of printing, it calls the function.
Oh, okay. I.
Oh, yeah. Alright, how does this work? Oh, this isn't gonna work. Yeah.
Good guess. Let me, I just realized another problem. There we go. Well, we don't want, it's not, well, what does the visit function take? It doesn't take a node, it takes a val, but we don't have val, because val is what's going to be received by the function. So we need a send, there we go, yep. All right. All right, we need to come up with some test case. Sure. This is going to be a terrible test case, but that's fine. For each. I'm going to call it the most amazing function ever, the do it function. Oh, did I say it returned an int? Oh, I'm being silly. One moment. And let's actually call the function. That's interesting. I'll visit and then, oh. Haha. You got this. Fix it. Hey, I'm glad we tested it. Too few arguments. We got to pass the function as well that we're going through, or a pointer to it. Hey, look at that. Now, why would we be doing this? Because it seems like a lot of extra work for something so meaningless.
We wanted to subtract 1 from every val.
Yeah, we could do that too. I like that. Or we could find the summation of it. Subtract 1 from each one. I like that. Ooh, I like that one a lot. Let's do that. Well, no, we can't because it's copying by value here. We'd have to copy by pointer. So we're going to do sum. Actually, we'll do that and then we're going to do sum. Oh, haha. Because I have a local variable and a function with the same name. That's going to end poorly. Yeah, there we go. Sum is 752. Perfect. And if we edited the function so you passed a pointer to it, then we could do what Alan was mentioning and actually subtract 1 from each one. All right. And there's tons of other things we can do. Do you see how this makes it more programmable, your data structure, so you can do different things with it? Yeah. So this is actually common to do. All right, great. Summary. Binary tree is either empty or has special node. Great. has two links. A node is a binary tree. It's called a leaf. It has no, all right, we were talking about no left child and no right children, sure. U is parent of V if there's a link going from U to V, not the other way around. The height of the binary tree is the number of nodes on the longest path. We have inner traversal, post, and pre. And root node's larger than every node on the left, and root node is less than everything on the right. Perfect. And we are done. We are done. Oh, any questions about binary trees? Or binary search trees? No?